Let's talk about definite integrals. For a lot of us, they can feel like a real chore, just long, tedious calculations. But what if I told you that a ton of them are actually clever puzzles, with these beautiful, elegant shortcuts hidden right in plain sight? Well, today, we're going to find them.
Okay, take a look at this thing, the integral of x cubed plus sine of x from negative pi to pi. I'm going to give you 5 seconds to solve it. Ready? Go. Time's up. Now, if your brain immediately started trying to remember antiderivatives and plugging in pi, you were working way too hard. The answer is 0, and you can figure that out almost instantly. So how on earth is that possible?
It's not impossible, not if you know the cheat codes. And that's exactly what we're diving into today. We're not just going to be solving problems. We're going to uncover the powerful tricks that let you see the answer, sometimes before you even pick up your pencil.
But before we get to the really cool tricks, we have to go over the basic rules of the game. Every good strategy is built on a solid foundation, right? Calculus is no different. So, there are 3 fundamental properties you just gotta have in your back pocket. First, if you flip the limits of integration, you just negate the answer. Simple. Second, if you're integrating a bunch of stuff added together, you can just break it apart into separate, smaller integrals. Super useful for simplifying things. And third, any constant that's multiplying your function, you can just pull it right out front. Got it? Good. All right, with the basics covered, let's unlock our first real superpower, symmetry. This is where the magic really starts to happen. And it is the absolute key to solving that monster problem from the beginning.
The whole idea really boils down to 2 types of functions, even and odd. An even function, like x squared, is a perfect mirror image across the y-axis. You plug in a negative x, you get the exact same result as if you plugged in a positive x. But an odd function, like x cubed, has this cool rotational symmetry around the origin. You plug in a negative x, and you get the negative of the original function. That simple little test is everything.
So let's actually visualize this, because an integral is really just the area under a curve. For an odd function, if you look at the area between, say, negative a and 0, you'll see it's trapped below the x-axis. We count that as negative area. But here's the punchline. Because of that perfect rotational symmetry, the positive chunk of area on the right side is the exact same size as the negative area on the left. They are a perfect mirror image, just flipped.
Which means they completely cancel each other out. The integral of any odd function over a symmetric interval from negative a to a is always 0. So think back to our first problem. X cubed is odd. Sine of x is odd. You add them together, the whole thing is odd. So the integral from negative pi to pi had to be 0. No calculation necessary.
Now, even functions have a pretty great shortcut too. Since they're perfectly mirrored across the y-axis, the area on the left is identical to the area on the right. So instead of integrating all the way from negative a to a, you can just find the area from 0 to a and double it. It makes the math way, way simpler. Okay, so symmetry is a huge one. But what about problems that don't have those nice, pretty symmetric limits from negative a to a? Don't worry, we've got some tricks for those too. Next up is what I call the limit change trick. This one feels a little bit like mathematical black magic. For any integral from a to b, you can literally replace every x inside your function with a plus b minus x, and the value of the integral stays exactly the same. It sounds bizarre, I know, but this one substitution can transform a ridiculously hard problem into something you can solve in a snap. And what about functions that repeat? Like sine or cosine waves? For those, we have the periodic function shortcut. If a function just does the same thing over and over again with a period of t, then the area under any one of those full periods is always the same. This means you can just shift your limits to whatever range is most convenient, usually 0 to t, to make your life way easier. So, we've covered a lot of ground. How in the world do you remember which trick to use and when? Well, that's where this comes in. Think of this as your field guide for spotting these shortcuts out in the wild. This is your cheat sheet. It's pretty simple. If you see symmetric limits, like negative 5 to 5, your first thought should be, is this function even or odd? If you see trig functions with limits like 0 to pi over 2, you should try the limit change trick. See a function that clearly repeats? That's a job for the periodic rule. Heck, there are even known results for specific combos like an exponential times a polynomial. The real key isn't just memorizing the rules. It's about training your brain to recognize the patterns. And this really brings us to the most important point. All of these shortcuts, they show us that math isn't just about grinding through calculations to get some number at the end.
It's a creative process. It's about seeing the underlying structure of a problem and finding the most efficient, the most elegant, really the most beautiful path to the solution. It's about looking at something complex and finding the simple truth hidden inside. So the real question to leave you with is, what patterns are you going to look for